Welcome to CASE. My name is Colleen Nagy. I'm the Director of the Program Management Office here in ITS at Case Western. And I'd like to introduce to you David Clute. David is has been working for Cisco since October 2000, and he's led the development of the Cisco's e-business strategy and roadmap for supporting the digital transformation of their connected real estate processes at Cisco. He is the customer solutions manager for the connected real estate area of Cisco. And he has 25 years of architecture, engineering, systems development, and implementation of applications for the infrastructure and corporate real estate industry. He is also a frequent speaker and author throughout the real estate design and construction industry for intelligent building design and building automation systems.
Well, I have to say it's much nicer to be here now than I was last time because it was a snowstorm. I think there was 6 or 8 inches of snow on the ground, and I was trapped in the airport. But it's beautiful to be here, and I thank you for coming. Before we get started, I would like to get a better sense of who's in the room in terms of background and experience, because the information I have can be really focused on the audience specifically. So we'll do it by raise of hands. How many people are in architecture, engineering, or facilities management in the room? Okay, 1. Okay, how about academics or instruction or in the faculty, either this university or other universities? Okay. And then others would be either administration, finance, or operations. Okay, so we've got a good cross-section of folks, and the topic, I mean, I could have easily labeled it going green, but green now means so many different things to so many people that we're trying to avoid kind of putting this topic into that category. So what it's really talking about, and what we do in our day-to-day business of this practice, is we talk about how to integrate technology and business processes and sustainable issues around the environment, economic issues, and socially responsible operations of buildings. But it really speaks to the entire life cycle of the built environment, from design and construction to operations. So we're going to touch on some high-level issues, things that people weren't even really thinking about a couple years ago until it really became mainstream. So I think it's helpful to reinforce some of these key concepts around environmental, economic, and socially responsible kind of definitions and issues, so we're all on the same page. And then we're going to talk about how these opportunities to implement technology in the built environment, buildings and infrastructure, communications and network services, and how all those things are interrelated. About maybe 8 or 9 years ago, there was a lot of interest in tying together data and voice and communications on a single network. And it used to be that the data guys and the voice guys, they were in different camps, so you could get them barely even to talk to each other. But when we started moving the phone systems onto the same network as voice and video and data, it changed the industry. It changed how people worked with each other and how IT and voice and data were working behind the scenes. We're getting into another realm now where we're looking at another big sea change in the industry, where building automation, facilities management, operations, design, and construction, in any given building, there may be 20 or 30 separate low-voltage control systems that control the lighting, or the temperature, or the ventilation, or the fire alarms. And those are all starting to migrate and move to the same network as our enterprise data, voice, and video systems. So it's kind of turning the industry upside down. The labor unions, the contractors, the architects and engineers that have designed and built buildings the same way for literally the last 50 or 60 or 100 years are facing a whole new paradigm shift. And to give you a good example, when building networks go into the construction phase, usually it's the low voltage wiring guys that come in late in the game after all of the structural systems, the ductwork, the big pipes, the ducts, the big wiring, the power generation. Those guys come in first and get their work done. And the low voltage wires come in last. Well, now we're changing all that. All the commissioning, the operations for the heating and ventilating, all the ductwork, the control systems, those are going to be running on the same network as our enterprise data systems. So those wiring systems, those structured cabling devices, have to go in early on. big change for the work environment. So we're going to touch on those issues as well. So some of the key concepts we're going to look at are in terms of sustainability and finding ways to reduce greenhouse gas emissions, specifically looking at carbon emissions, controlling hazardous materials and waste streams. There's tremendous interest now in the economic factors. It used to be 5 years ago we'd talk about saving energy and reducing capital or operational expense. And people would say, yeah, that's all very interesting, but we only have a fixed budget. We don't have room for all this fluffy stuff. We'll do it if we have time, but most often it would get removed from the budget as part of value engineering. And I like to call value engineering value extraction, because usually the stuff that makes the most sense long term for the life of the buildings gets pulled out in the interest of expedient near-term initial capital budgets. But what we're finding is that it makes really good economic sense to look at the whole life cycle of the buildings and think about how we can lower operational expense by investing maybe 1 or 2% more at the beginning. And we're also finding that if with proper planning, we can implement these intelligent systems at the beginning at the same or even lower cost than what people would think they would have to spend. And of course, there's lots of really good reasons in terms of attaining social responsibility goals and really looking at how these buildings are designed and constructed. But one of the big factors that we're dealing with is that buildings are responsible for 50% of energy use in the built environment. Transportation and manufacturing take the other 25 and add up to the 100%. But buildings, and Colleen and I were just talking before the meeting about how in the wintertime you can go into some of the buildings and you have to open the windows because they're so incredibly hot in the dead of winter. That's not the good use of our fossil fuels. And it all happens because the buildings may have a legacy building control system that could be literally 30 or 40 years old. There's a thermostat sending a signal to either a boiler or an air handling system that sends temperature to all the rooms at the same temperature, and there's no way to individually control the settings. Well, the whole revolution that's happening is that we're using automation and building controls and technology to really fine-tune the way that the environment and the buildings respond to the conditions of the occupants and the buildings and people in the room. So energy consumption is certainly a key indicator and a reason that we're looking at these smart and intelligent buildings. Also, there's just tremendous interest now in change in policy and regulation, and this dated back, a number of years long before our current administration, but we're getting a big push now, and our business cases and the reasons that we're doing this is getting a whole lot easier now because there's a general awareness of what is sustainability, what are LEED certified buildings, what are the policies and procedures driving us in this direction. There's also tremendous momentum globally. Every other major developed country and even non-developed countries are looking at standards that look at what we call eco-labels or industry standards. I think we have to credit the U.S. Green Building Council with really starting this initiative. There's also been a number of groups in Europe and other parts of the globe, but these global eco-labels and industry standards, it's really raising a common awareness of how to go green and how to be sustainable on a global level. But in looking at different initiatives, global initiatives that are enabling these policy principles and creating regulatory frameworks, driving tremendous innovation in solutions and partnerships with the research institutions. I mean, Case Western is a great example. There are a number of facilities really across the country, around the globe, that are changing their research programs, changing their curriculums to align with regulatory and environmental momentum. And like I said earlier, the business case is getting a whole lot easier to justify because the costs are coming down, a lot of the technologies are being commoditized, and it's just getting a whole lot easier to implement a lot of these technologies. We're also seeing behavioral change. And when people understand that they can lower their costs, they can be more efficient, they can make the buildings safer and much more productive by lowering the thermostat a couple of degrees. And this is not new stuff. This, literally dates back to 70s and 80s with the first environmental movement, but we didn't have the tools to automate a lot of these things, and we relied on human behavior and the lessons of our parents saying, keep the refrigerator closed, turn off the lights, turn down the heat. Well, as the buildings become more intelligent, they can do all this stuff automatically based on who's in the building. And so now, through sensing devices and automated control systems, the buildings will respond to the occupancy without us having to even think about it. Lighting levels, temperature levels, air movement, and the combination of green plus smart, creating smart, green, intelligent buildings is creating a real revolution across the industry. And it's very exciting because now we're getting information and communications technologies. The acronym IT has been very commonly used, but you'll start to see ICT picking up adoption, where communications, and it's driving traffic on the internet to an unprecedented degree. It's not so much the human interaction. Certainly it's things like all the videos and YouTube and all the traffic on the internet. But that amount of traffic is going to be dwarfed by the amount of traffic between machine-to-machine communications, where sensor networks and devices are sending data from all the systems within a building up into these control systems to automate the environments. So we're seeing the use of ICT in substituting for travel, changing road transportation, smart buildings. And then another very exciting area is the dialogue that will start to happen between the utility systems and the buildings themselves. And again, this will be a machine-to-machine dialogue where the buildings will inform the grid of how much energy do they need at what point of time during the day. And so we're going to enable this conversation between machines where the power generation and the distribution of the utility and the grid figure out, well, what does the building need at this point in time? And our billing systems will then follow to see how are we going to pay for that and use it. So all this momentum of policy and regulation change is a call to action at the government level, at the local level, and at an individual level. Because as people become more aware of their impact, they're happy to change their behavior if they have the tools to do so. And if the buildings are making it easier and more responsive, so much the better. So let's talk a little bit about what it means in terms of the transformational change in the networks themselves. And we'll talk about buildings and people and services and what this technology stack looks like. And we like to think of it as a building block or a framework, and at the foundation of that is the building information network itself. And that's the physical layer of the fiber optic cables, the copper, the wireless systems that creates the infrastructure or the fabric within the buildings to enable these things to happen. And it's just like a plumbing system. You can't transport water from point A to point B unless it's connected by piping. Same with information. We can't really take advantage of all the data coming from these subsystems unless they're literally connected in some way. So that means that physical layer, the building information network, needs to have a well thought out and planned structured cabling system that not only connects the rooms within a building, but buildings to buildings and buildings to campuses and campuses to the community and so on. So we're fortunate enough to have been involved with some of this development globally. And for economic reasons, we've seen a lot of this innovation take place in the Middle East, Dubai and Saudi Arabia and Abu Dhabi. That's changed in recent months, but there's still a lot of momentum and innovation taking place that we can leverage and take full advantage here at home. So on top of that foundation are the building technologies, and those kind of fall in three major buckets. There's the building automation systems, then there's the voice and video and data components, and the physical security systems. So the cameras, the access controls, and I think as people become more aware of how many cameras are now in our daily lives, I mean, you can't walk into airports or any of the big box retailers now. I was talking to one of my colleagues earlier this morning about how many cameras do you see in like a Costco or a Walmart or Best Buy. Now, all those camera domes, they might not actually have cameras behind them, but there's an awareness that we are being observed and monitored and watched all the time. And it's not because we're a paranoid society, maybe some of us are, but it's mainly we want more intelligence. We want more data about the occupants and the users so we can inform the buildings and the operations to make it more efficient, more optimized. And then on the next layer in the stack are the unified communications, enabling audio and voice and video communications as part of all that. So that stack, this building technologies, the physical security, and the unified communications, creates our ability to offer services in a way that we haven't been able to before. And think of it as a hotel that you now have access to services that you may not have had before because these systems are talking to each other. So the objectives in terms of measuring and monitoring and marketing these different services really fall into these three categories or value propositions of environmental reasons, economic reasons, socially responsible reasons. So it's driving our collective desire to reduce greenhouse gas emissions, reduce our carbon footprint, but we don't really know how effective we're being unless we can measure it. And measurement comes from collection and analysis of data. We also want to increase our personal contribution and to the overall globalization effort of reducing the carbon footprints and making our whole sense of the environment more efficient. And again, it's through being able to collect and analyze and use the data that comes from these subsystems. So it means we're driving towards what we call a network-based green strategy of using the Internet Protocol. TCPIP is kind of the ultimate level of data and information. Years ago, maybe 40, 50 years ago, the ultimate open standard in communication of building systems was air. Air was used in pneumatic tubes to drive signals about pressures and differential pressures between control devices, and these pneumatic tubes would help us optimize building performance in these control systems. Well, now instead of bursts of air, we're using packets of IP data to send information between people and services and building technologies to drive towards this strategy. So let's talk a little bit more about what we mean by the built environment and physical infrastructure within the buildings. So if we tie these back to our goals, within the energy management systems, we're going to be using integrated building automation systems, put those on the same network as the data, the voice, and the video to drive control of the building. The data centers and labs, in particular within Cisco's portfolio, we've got about 20 million square feet, 400 buildings worldwide, and we use a ton of energy in our data centers. So there's been a big push to figure out how to reduce the cooling load, the electrical load in our own data centers through optimizing it and tying it into these automation systems. Within the building design and construction themselves, our goal is to reduce the duplication of product and labor, make those building solutions more green themselves through collaboration and these connected real estate solutions. So there's lots of opportunities within the buildings themselves to achieve these goals. And we'll run through a few different examples. Certainly during construction, just if you were to be involved in a construction project and monitor the amount of waste that comes from building materials, and just even on a house, if you look at the amount of wood, spare wood that's cut from the framing, or waste drywall, and normally it goes into a big dumpster. Well, what if we could divert that waste material, recycle it, and reuse it? Concrete, steel, drywall, wood. These are expensive materials, and if you're remodeling a house or dealing with construction projects, you'll know how expensive these are. And so what we're trying to do is really reuse the materials a lot more efficiently. But if we can't use them in the building project, let's at least recycle them and divert them from the landfills. So the way we address this in our practice is what we call connected real estate. And tying this into intelligent buildings is a term we use to describe how the Internet Protocol can be used during the construction and operations of the building for converged building, data processing, and communication systems. So it's really taking intelligent buildings, an idea that's really been around since the mid-'80s, but enabling it through technology and communications to drive energy conservation and more efficient use of the assets. And thankfully, the U.S. Green Building Council came out with the LEED standard. It's getting broad adoption now. I think a lot of people, if they haven't heard of this standard, leadership in energy and environmental design, then they will hear about it very soon, because it certainly has become mainstream. I think every new building or every developer or architect or engineer that isn't already thinking about it are being asked to think about it by the people funding the building. Whether it's a government building or private sector or even buildings here on the campus, there's an awareness that we need to think about, well, is it LEED certified? What do we need to do to get it LEED certified? And if not, why not? And there's different levels. But I want to point out that being green and being LEED certified is just kind of half of the opportunity. The other half is making these buildings smarter through what we call the Building Intelligence Quotient, or the BIQ. And so if we can get smart green buildings, that's so much the better. And that's what we're striving to do. So let's look at some facts and figures on green buildings. The next generation of the workforce, the people that are making decisions about the built environment, choose brands that are aligned with social causes. There's a high percentage of folks that want to be sure that the design and construction is well aligned with these environmental issues. But some of the big challenges we have, particularly here in the US, is that we don't have as many opportunities for new construction as we have in other parts of the world. We're not building brand new cities from scratch like they are in China or India or other parts of the world. So we have to deal with the renovation and retrofit challenge. And retrofitting a building is much more difficult than building it from scratch. And from a professional perspective, it's a lot easier to start with a clean slate and go from the ground up. But the real challenge and the opportunity is improving the efficiency of the existing built environment through some really pretty easy things of just changing the temperature controls, switching out the lighting. I think we're all becoming much more aware of different lighting systems that are available now. Even Home Depot, you can't walk into Home Depot without going down the lighting aisle, and there's a whole section now on smart lighting. And it's really kind of exciting to see, because we're seeing theory and practice literally changing very quickly. And what that allows us to do is change our operational budgets, lower our costs of energy, reduce our utility costs, save on water costs, and the net result of that long term is our buildings and our real estate assets are going to increase in value, and the assets themselves will become more valuable, which may offset some of the downturn we've seen in the economic market. Another interesting definition to learn about is something called net zero buildings, or ZEB buildings. And this means that the net energy consumption is, we're trying to zero it out so that the energy used to operate and maintain the building is offset by other sources, either through renewable energy sources or conservation measures or more efficient use of the building systems themselves. The other thing we're seeing here is that the use of 3D computer animated modeling and simulation during design and construction is helping us get there a whole lot sooner. Interestingly enough, design and construction, the industry as a whole, has actually declined in productivity over the last 2 decades compared to manufacturing, automotive, aerospace, IT, who have had tremendous increases in productivity and efficiency through the adoption of technology. Construction is slow to adopt, and that's because real estate design and construction is inherently a very manual, custom process and very fragmented. It's very difficult to find common data standards across real estate. But this is one that's getting a lot of interest, and I think we'll see municipalities, government agencies. The city of Austin, Texas, I think, is one of the first to actually implement in their energy plan that within 10 years, any new building will be a net zero building. On a larger scale, the Masdar project in Abu Dhabi is creating a zero carbon city on a very large scale. So we're seeing some very exciting things happen in this area, but you'll start to hear a lot more about net zero buildings. Real estate is a huge contributor to energy use and greenhouse gas emissions. And if you break it down, the biggest contributor there is heating, cooling, and ventilation. And certainly the older buildings are huge users of fossil fuels. And whatever we can do to change that is not only going to help the budget, but also improve the comfort and efficiency of the buildings themselves. If we look at how do converged energy systems really help us, well, one is monitoring and control, just being able to get a good sense of how much electricity are we using, and how can we feed that information back to the end users in the building. We've recently introduced a new solution we call Green Aware, and it's taking all the data feeds from all these subsystems in the building, normalizing them through XML middleware software, and then making them available as a web page or on a digital display so that people can see real time, well, how much electricity are we using in this building? And if I turn down the lights or if I take the stairs instead of the elevator, is it going to have any impact? And we want to be able to have people get an immediate feedback loop of the change in their behavior. Rick Fedrizzi is the CEO of the U.S. Green Building Council, and he had a great idea. He said we should redesign shower valves at home, especially for households that have teenage boys, that when they turn up the thermostat or turn up the shower, it's got to have a timer on it that shows dollar amounts that is subtracted from their allowance. So there's immediate feedback loop on changing our behavior on systems in our homes. We need to do the same thing in our commercial buildings. So we want these real-time feedback loops on our energy systems. Connecting buildings to management systems, the accounting, the ERP systems, the operational maintenance management controls. There are so many different applications and subsystems in the buildings that don't talk to each other. Just simple aggregation of data, standardization of definitions, and things that can be done with an Excel spreadsheet and some brain power can have a huge impact on reducing the cost and operation of our buildings. So we're doing a lot of different things to enable systems to give us that real-time feedback. Now this diagram's worth, I think, a little more of a deep dive because it gives us a visual representation of the logical network that we touch and feel and deal with every day as end users. And what are the systems behind that? So we talk about logical networks and physical networks. The physical networks are all of these different sub-devices we talk about. So the structured cabling system allows us to connect all the facility systems that are kind of here on the left-hand side, and we've talked about a few of them. HVAC controls, energy and power monitoring, fire alarms, air handling, boilers, chillers, lighting controls. And in any large complex building, there may be 20, 25, 30 of these separate low voltage systems that traditionally have been in their own silos. They've had their own hardware, their own software, their own cabling. And that means that you need to have people that understand those subsystems. And this is where the big challenge is coming in, is that if you look at the demographics of people that operate and maintain buildings, oddly enough, a large percentage of building engineers are retired Navy veterans that have come out of the military and understand boilers and chillers and building plants. This is particularly true in large urban areas, central business districts, and if you get into the guts of the buildings, the people that are running the building are getting close to retirement age, and they're going to be leaving the workforce, and it's leaving this huge gap of, well, who's going to operate and maintain the buildings? Well, folks coming out of school are not real excited about becoming building engineers. They'd much rather become system integration specialists that tie together security systems and building automation controls, and they monitor it and use it through the same interfaces and tools that they use in college. They want to be able to control the building on their iPhone. They want to do it remotely, and if they get an alert on their pager, their iPhone, or their PDA that they need to change a setting in the building, they may want to be able to do that remotely and over the web. This is also introducing some very interesting new business models and business opportunities for companies that are creating new data centers and service models that can remotely control and monitor and support building operations from anywhere, literally anywhere on the planet. There's a new company in Dubai called Pacific Controls. It's a small, fairly young company, maybe 50 people. Their workforce consists of people in their 20s and 30s that are very proficient at automated tools, but they're controlling the mechanical systems, the security systems, safety, and they have become remote concierge service providers for vast portfolios of new buildings because of the way they've put together this converged architecture. And they're making a lot of money from it because it's new service offerings and new business models that are creating green-collar jobs that we're going to start to see a lot of and that people are talking about here. But I think that this is a good illustration of what it means to aggregate all these subsystems, tie them together with a common network infrastructure layer. In the middle, you've got interactive services and middleware that make it possible for all these disparate hardware and software systems to pull that data from historically different sources and get them into one console, one web interface that we can then work with as a group to manage all these disparate systems. And we talk about different levels of convergence in building automation. Level 0 means that all of these subsystems are still in their own silos. They don't talk to each other, they're still separated, and they exist on their own. Level 1 is where we at least have a common network cabling system where the structured cabling reaches all parts of the building, and we're starting to put these physical layers onto the same network. Level 2 means the end devices are connected to the IP network through IP controllers. So if I go back a slide for a minute, at this level right up here, before it gets onto the network, there's all these different controllers that are taking feeds from all the endpoint devices and getting them onto the same network and talking to each other is what we call level 2. Level 3, they're now integrated through systems logic, middleware software, and full convergence is where all these systems are now integrated, they're talking to each other, they're optimized, and they're made available as web services to the enterprise systems and applications on the network. So let's take a look at what this means during construction. Typically, if we look at the level of effort and the life cycle of a building, and buildings nowadays are designed for 50 or 60-year life cycles, design and construction really only takes up about 25% of the total cost of a building. Operations is the other 3/4 of the total budget for that whole life cycle. The greatest ability to change the cost or impact the building design is really at the beginning, because as you get further into that cycle, the cost and impact of change orders goes up dramatically. And historically, IT network design happened late in the game, late in construction when all of the other subsystems have already been figured out. So what we've been advocating now for quite a while is at the owner and architect and engineering level, think about building and workplace design and integrate the network into that design earlier. And it's even better if you get it included as a line item in the budget, as a pro forma that says, this will be an integrated building. The workplace, the IT design, all the subsystems will be integrated in the same way that an integrated design for an airplane or a car or a ship is thought about ahead of time and created in a 3D digital model ahead of time. And that too has become a big change recently, where the cost of doing 3D modeling and simulation has come way down. In fact, it's free now. You can go to Google SketchUp, download a very powerful 3D modeling and simulation program to create building designs, and it's gaining wide adoption. And when I started doing this 20 years ago, to do what we do now on Google SketchUp took a $500,000 CAD workstation. And it wasn't nearly as easy to use as Google SketchUp. So these kind of changes are making it a whole lot easier to do these integrated building designs sooner, and the excuses that it costs too much or it's too hard or we don't have the training, those excuses are disappearing, and pretty soon there won't be a reason not to have a three-dimensional, fully integrated 3D computer model of the building, including all of the subsystems, even before you break ground. And that's going to save a ton of money in change orders, because if you think about it now, a lot of the technical integration components of mechanical, electrical systems, ductwork with beams, pipes with plumbing, all the integration and complexity of 3D modeling in a building, even today, sometimes it's worked out in the field because they didn't model it, they didn't figure out ahead of time. And believe me, moving a duct or changing a beam or drilling a hole in the concrete is a whole lot cheaper and easier in the computer than it is using the concrete eraser on the job site. So where are these savings being identified and documented? And even 2 years ago, we didn't have a really good record of these case studies that would help us drive business decisions. But now we've got a good backlog of case studies that show that integration of these systems will save big money in service contracts, additions and remodeling. Energy costs are way down, maintenance and repair, training, cable pathways. And these all add up to savings and tools that we can use to much more easily justify the business cases. There's a lot of really good information in here that we've been compiling literally for the last 5 to 7 years based on our internal practices at Cisco, but now a broad ecosystem of partners, architects, engineers, government agencies, cities, campuses, and there's just a wealth of really good information that I want to share with folks. But why don't we open it up for the last 5 minutes for any questions or open discussion that people would like to have.
From a build standpoint, where do you want to enter the process with the URS?
Let me go back to this chart right here. We really are advocating to the owners and the ultimate funding sources is let's get this discussion in the design team engaged in early planning. And in the normal cycle, it's what we would call schematic or concept design. And usually the folks that are thinking about Cisco hardware and software and systems, they say, oh, those are the hardware guys. They don't come until the end. But engage us early on, and we've got documented ways of reducing capital expense and saving significantly on operational expense budgets as a member of the design team very early on. Just as you would the architect or the structural engineer, bring on your ICT consultant as a core member of the design team from the very beginning.
So does Cisco provide to your partners, the resellers, ICT experts that can come out and work with them?
Yes, I'm part of an advisory services group, so I'm an engineering consultant within Cisco that works with our partners and our consultants and our customers to provide this type of consulting expertise. But it's not just my group. We're now training quite a number of our own channel partners to become CRE experts and CRE consultants. And many architects and engineers now are understanding connected real estate as a concept and a model. But the key is get engaged early and have this conversation about integrated design, even in the planning and budgeting processes. But as Cisco, we do offer that as well.
So one last question. Clearly a greenfield approach makes sense.
It's a lot easier, yeah.
That's not going to play in everybody's sandbox for a bunch of reasons. They already own buildings, they're not going to tear them down, historical landmarks, all that kind of stuff.
Retrofit, there's as compelling and as a powerful business case on rebuilds and retrofits as new buildings.
So, and that's my question, what's the business case for that that could be demonstrable for somebody?
It's a little harder, but the key there is getting a good record of the legacy costs of utility bills and performance information for the building. In fact, the project we're doing here, our first meeting is this afternoon to be collecting data on 3 buildings here on the campus. And one of my first questions is, give me all the utility bills for the last 5-10 years. And so that information about the existing built environment is key to understanding the as-is current state of the building. So we can figure out what is the future state, what can we do, what are the opportunities in changing the building without a huge expense, because we can't go in and rip out all the subsystems. It's not going to happen. But what can we do on an incremental basis to begin to create a cost model or financial model that allows us to change the buildings over time? Yes.
Are you doing these 3 building renovations? Are you going to do a baseline emissions measurement as well?
The first project, the pilot project, is really an assessment and looking at the 3 buildings to figure out what's there now and then make recommendations at the end of the phase 1 study as to what are the potential opportunities going forward, tied to a financial business case with a whole menu of options that, if you had unlimited funds, you'd do all these things. If you have 0 money, you still do these things. And it'll probably start with some operational changes and behavioral changes that we can do fairly quickly and easily at pretty low cost.
We aren't doing baseline emissions because we think that's part of the bigger savings would be in energy.
We're going to take one of the buildings and do a pretty detailed lead analysis on one of the facilities. But then on all 3 of the buildings, we're going to look at building intelligence ratings and look at how we can suggest improvements on all 3 buildings, but provide a tool at the end, a cost modeling tool that can be applied to the entire portfolio. But in looking at baseline emissions for all the buildings, some of that's included, but that's a much more comprehensive scope beyond our first pilot project. With any luck, we'll be here a long time. I think we're about out of time. Maybe one more question.
When you're talking about connected buildings and pulling all of this information together, since this information can be used to actually affect the building, are you doing that across private networks, or how are you dealing with the fact that that information is available via the internet, and are you using any technology to encrypt the information?
Yes, this is a big concern because the legacy protocols that are used in building automation systems are inherently not secure in an IP environment. The most common ones are BACnet, Modbus, LawnWorks. They were designed to operate on their own isolated, secure networks that no one could get to except people that had physical access. When we put this information on the IP backbone and potentially making it available to a lot more people, we're doing so with the same security provisioning that we do with all of our other enterprise data through VLAN segmentation, firewalls, and securing the packet traffic in the same way we do data, voice, and video.
Okay, good.
And it's a big concern because the legacy protocols were not designed to operate in an IP environment.
Right, and when you stop and think of recently, there was intrusion into the electric backbones on the system.
Exactly, yeah.
You know, if you started having intelligence built into the building, then you could have an effect.
Sure. I mean, a favorite pursuit of graduate students with too much time is changing the chiller set points or the temperature settings in their professor's lecture hall.
It's happening already.
So we'll certainly take steps to avoid that.
Thank you.
I thank everyone for coming and appreciate your time and interest.
Thanks, Dave.
Sure.